is Cody, and I'm here with the Emerald Coast Science Center. Today we are going to be talking about amphibians and reptiles. So right here I have Claire. She is one of our leopard geckos. She's really sweet. She is a gecko, right? So she's a lizard, which is a reptile, right? And so I have before me a few things, and we can talk about, one thing I wanted to talk about first was salamanders. Salamanders look a lot like lizards, don't they? They have 4 limbs. The difference though, I have a picture of a salamander right here. Here's a fire salamander. If you look at the salamander, it kind of looks like he's got a frog head with the lizard's body. Doesn't it look like that? He's got like a frog head up here, the lizard's body. There are some differences that you can tell between the lizard and the salamander, and I'll tell you those right now. So if you look up close to the feet of the salamander, he doesn't have any claws. So amphibians cannot produce keratin. There's a small number that can. Those are just kind of the odd ones out. They can't produce keratin, and keratin is used a lot with reptiles. So have you ever seen, so let's see here, I got this big turtle shell right here behind me. That's all made out of keratin. Keratin is the hard part of the shell. My fingernails are made out of keratin. So lizards have claws. If you can see her claws, Claire's gonna get a little close to you. She's got some small little claws. They're not too sharp, but she does have these little claws so she can scratch onto, climb onto things. Geckos are really good climbers. They usually have padding on their feet. Salamanders are not gonna have any padding on their feet. But let's talk about the life cycles of amphibians. So with a salamander, with the lizards, they have eggs, right? Reptiles have eggs, and so they're gonna come out of eggs, and they're gonna look like little hatchlings. They're gonna be really, really tall, tiny, but they're gonna look exactly how they're gonna look when they grow up. They're just gonna be really small adults, right? And so then they're gonna grow up and pretty much look basically what they look like. But let me go ahead and put Claire up for a second. With the salamander, I bent the paper a little bit. So it starts out in the egg, and with amphibians, eggs are only going to last for a short amount of time. They're going to start coming out of their eggs after usually about a week, so it's about 7 to 10 days around there. Then they'll start to form. Whenever amphibians go throughout their life cycle, in order for an amphibian to be an amphibian, it has to first have gills and then grow up and have lungs, right? There are some exceptions where the salamanders won't go on land and they'll stay in the water and they'll keep their gills forever, but we still call those amphibians because they have close family species that will still come up out of the water and have lungs. So whenever you see, it'll come out of the egg and it'll show a little larva. So that little larva right there is still in the water, and then he's going to start to grow limbs. So you can see the limbs starting to grow, and he's got those gills poking out right there at the top. And then after a while, he's going to grow his 4th limbs, his back legs, and eventually come out of the water. He's going to lose his gills up here, and then he's going to be a terrestrial salamander. And you're able to tell salamanders aren't going to have scaly skin like our reptile friends are, right? So salamanders have glands that are close to the top of the surface of their skin where they can secrete stuff. Sometimes they'll secrete poison to stay away from predators, where reptiles can't secrete poison onto their skin, right? They have scales, like Claire does. They have scales made out of keratin, and underneath those scales are her skin. But you can see she's actually shedding some of those scales, which are made out of keratin. And so salamanders wouldn't be doing this, right? You can see that. And also salamanders are going to have, oh, she's going crazy now. Salamanders are going to have webbing on their feet. You can see, she's going crazy. You can see with Claire, she does not have any webbing on her feet. She's not going to be swimming around. She's going crazy. I'm going to put her away so she doesn't get any more angry, so she can calm down. But yeah, so salamanders are going to have webbing on their feet because they like to swim a lot. And then let's go ahead and show you the life cycle of some frogs, right? And so first off, at the beginning of a frog, we're going to have these little tiny eggs. So the eggs between an amphibian and a reptile look a lot different. These are some bearded dragon eggs. When they first come out, they're white. These kind of got cooked in the lights that we have that are warming up our reptiles because they're cold-blooded. Amphibians are cold-blooded too, but they like to be around water so that they can stay damp and so they won't dry out. Whereas reptiles, they can dry out and still be okay. So these are white at first, and you can see they're single eggs. They usually lay them in a clutch. And then these are what the eggs look like of frogs or other amphibians, right? They form it into like a big jelly sack. It's kind of all mixed together and it looks kind of like this. And then usually with frogs, they'll usually put them, they'll usually lay the eggs in the water so that they can come out of the water. They'll just poke out of the water like this as a tadpole. But there are some amphibians, like the red-eyed tree frog, where the red-eyed tree frog will actually, let me go ahead and see if I can draw it. So let's say there's a pond right here, if you can see that. Sorry, I moved on our camera woman. All right, so say there's a pond right here, right? This is all a bunch of water. What red-eyed tree frogs will do is, let's say there's a nice big tall plant right here with a big leaf. And that leaf goes like that. The leaf is hanging over top of the water, and so what red-eyed tree frogs will do, it's really, really cool. The female will lay the eggs right here on top of the leaf, and so how the eggs become fertilized is through external fertilization. So a lot of times with a lot of animals, they're internally fertilized, but the female will sit right here, lay the eggs, and then we'll have a male right there at the back that's going to fertilize the eggs. It's going to put his genes into the eggs so they can make new frogs, right? New red-eyed tree frogs. And so all of those eggs are going to be laid right here on top of this leaf. And then whenever they're ready to turn into tadpoles, like I said, it doesn't last very long, they're going to drop into the tadpole and drop straight into the water. And they keep them out of the water so that they can, and kind of hidden in the leaves to hide from predators. And so then sometimes predators will catch them as they're falling if they can find out where they are. But once they're in the water, they're pretty safe. And so that's what red-eyed tree frogs would do. But a lot of times we'll have frogs that would just lay them like connected to some plants, like some bushes that are kind of in the water. And so they'll kind of stick to the stems. But then we'll have this tadpole, right? A tadpole is going to breathe with the gills. It doesn't have lungs, so it's still breathing underwater. And then it's going to grow these back legs. You see the back legs right there? So yeah, so he's going to have those back legs, and it will slowly start to form all four of his legs. And then once he's got all four of his legs, he's going to start growing lungs after this. Lungs is how we breathe our air, right? We'll breathing in that air, and then it's diffusing the oxygen into my lungs, into my bloodstream. But with gills, it takes the oxygen from the water and diffuses it into the bloodstream from the outside. So it's kind of like an outwards lung, which is pretty cool. Pretty cool to think about. And then after it's done getting its gills, we got an amphibian, and they have these glands right down top of the skin that secrete mucus, so that he's constantly kind of damp and wet, so he's never drying out. But that's the life cycle of a frog. You can see right here, it's a little bit better, and these are real life frogs, so they're not toys. So there's the tadpoles that are growing, and then grows the back legs, forelegs, and then he starts to lose his tail. Once he gets those four legs, he starts to lose that tail, and that's how you know he's ready to go up on land. Whenever he's lost his tail, he's got his gills back, which is pretty cool. The development of a frog. And so we talked about salamanders, we talked about lizards, how they're a little different. Let's talk about turtles. So right here, this is what the turtle looks like when it's inside of the egg. So right here, let's go ahead and show you what the eggs look like of some certain sea turtles. So we got a hawksbill sea turtle right here. All the way down, we got a leatherback sea turtle. Leatherback sea turtle is really, really big. And so I can show you some of these turtles that we have behind me. So right here, these are fit to size. So these are how big the sea turtles are. So right here, I have a Kemp's Ridley sea turtle. Really, really pretty. Yeah, Kemp's Ridley. And then this Kemp's Ridley matches right here, the Ridley sea turtle. So there's a few different types of Ridley sea turtles, but they're all about the same size, and that's how big the egg is. And so we can go over, all right, we got the loggerhead right here. Whoa, it's a big one. This is how big that dude is. It's really big, bigger than me, huh? Yeah, it's pretty big. And so what I can do is I can show you the egg that matches it. Loggerhead right there. The egg doesn't look too big, huh? But then, I think this is a green sea turtle. I'm not too sure. I'm pretty sure it is. This is the green sea turtle. Pretty big too. And this is his egg over here. The green sea turtle. We don't have the leatherback sea turtle. If we had the leatherback, that would be really big. It'd be really, really wide, which is really cool. But I wanted to show you what the turtle looks like when it's in the egg. So you never get to see how the turtle's forming when it's in the egg, right? So I'll go ahead and show you. So right here, it's in the yolk, right? It looks kind of just like a chicken egg. You see that little thing? And it starts to grow this long line. And that long line is its spine. And we'll see that the spine will eventually turn into the shell. And so the spine keeps growing. You see, right at this moment, around stage 15, we start to have something called cephalization, which is when it starts to grow a head. And so you can see the head right here. Let me get a little bit closer. You can see the head right there up top. And the long tail that turns into the spine. That'll eventually, you can see right here how it's starting to curve. It'll turn into the shell. So then it starts to form that shell, and you'll see that the spine will just start to grow out like this to where the shell show up. And then I can actually show you, I did not clean this. I was out taking pictures of nature, and then I saw a sea turtle, or not a sea turtle, just a regular turtle shell, and I went to grab it, and I found there wasn't any turtle in it, sadly, but I did see the shell right here, and so I can't even put these gloves on the right way. But something I wanted to show you was you can totally see the spine right there inside the shell. You see how the spine goes along the shell right there? And so that spine will grow out this way, and it'll form that shell that you can see. And I also had the hip bone, the pelvis of the sea turtle, but it got destroyed. Sadly, it got stepped on. But that's okay. I'm gonna try and put the pelvis back onto the turtle later on. I'm trying to super glue it. But that's super cool. I wanted to show you that. Yeah. All right. And so let me go ahead. Oh, Claire's all hiding. Something that's really cool about geckos is they can lose their tails, right? They can lose their tails and they'll be able to grow them back like Claire can. But something that's even cooler about the salamanders is they can do it too, but they can do it a lot better. So they could lose an arm and they'd be able to grow it back. They can lose limbs and grow them back, which is really fascinating. I really want to know what makes them do that so well. But this is able to show you the differences between lizards and salamanders, and pretty much just amphibians and reptiles altogether. Even though they're both cold-blooded, right? They still have some differences, like the skin. She's got this scaly skin made out of keratin with the skin underneath, right? And then the salamanders just have the moist skin that's covered in glands that allows them to produce mucus, allows them to have poisonous stuff on their back, poisonous mucus, that if people touch it, they could die. But it's really cool just to learn all the cool little side attributes of these animals so we can learn more about them. Alright, y'all. That is about all for today. We hope you enjoyed the little run through of the animals. And we will be back with y'all on Monday for another live video at 10 o'clock. Thanks.